While green hydrogen promises to play a significant role in the decarbonization of our energy infrastructure, it won't be as simple as throwing a switch. Rather, hydrogen made from solar and wind power will coexist with other energy sources for many years yet to come. And one key avenue for it is to leverage the existing natural gas distribution networks currently in place to deliver a blend of green hydrogen and traditional natural gas to the homes, buildings, and industries that currently rely on natural gas in full. Hello, my name is Keith Larson, publisher of Control Magazine and ControlGlobal.com, and you're listening to a Solution Spotlight edition of our Control Amplified podcast, sponsored this week by Six Sensor Intelligence. Joining me today to discuss some of the unique challenges posed by blending hydrogen into our natural gas systems and some of the technologies that can address these challenges in a cost-effective way is Duane Harris, Market Product Manager for SIG. Welcome, Duane, and a real pleasure to have you join us today.
Thank you, Keith. It's really appreciate the invitation. And I joined SIG in March of 2020 and have had an opportunity to spend 4 decades in our industry. And I've been looking forward to our chat today.
Awesome. Well, maybe just to start to lay some groundwork maybe you just take a few minutes to really update our listeners on some of the recent activities, especially I know in Europe, very active to begin blending hydrogen with natural gas to help deliver comparable energy flows with lower carbon emission.
Sure. And so, in so many areas, the United States leads the world in technology and research. However, we must admit, regarding the blending of hydrogen with natural gas to really help deliver comparable energy flows with that lower carbon emissions. Europe is generally, I would say, 5 to 10 years ahead of the United States in our research efforts today. Now, fortunately, there is really great collaboration between the United States and Europe to better understand really, how can we utilize the testing that they have conducted in Europe and the testing that we have been doing here in the US to really kind of effectively blend hydrogen with natural gas to lower carbon emissions here in the US and really looking at that from a world type perspective.
Yeah, that makes a lot of sense. I mean, while hydrogen and natural gas are both combustible sources of energy, there's some important differences too between the molecules that go into each. Can you kind of walk us through some of the differences and how that affects the dynamics within the pipelines and such?
Absolutely, and that really is a great kind of clarifying question, Keith. And that is, first off, if you look at hydrogen is 8 times lighter than natural gas. I mean, to think of just hydrogen itself being 8 times lighter than natural gas. And then if you start looking at the speed of sound, and some of you may be kind of scratching your head, well, why is speed of sound important? Well, if you use ultrasonic meters to measure gas, the speed of sound of that natural gas is really critical. And what you see is that hydrogen has a 3 times higher speed of sound than what you see in natural gas. And so, to take and quantify that, the speed of sound that we are used to seeing here in the United States is around 1,394 feet per second for the speed of sound that goes through the natural gas blends that we see in the US today. Mm-hmm. Well, if you are going to move hydrogen, the speed of sound of hydrogen operates at 4,300 feet per second. And so, I mean, that is just significant differences that your average person in looking at that kind of diagnostic would say something is off. And so, all that really has to be brought into our research and quantification. And in another area that I think a lot of people might even have a misconception, and that would relate to the heating value. The heating value of natural gas that you see moving in homes today throughout the United States really operates right around 950 to 1,050 BTUs per cubic foot,
Okay.
where the BTU of hydrogen is really 3 times lower. It runs at 325 BTUs per cubic foot. That is significantly different whenever somebody is starting to look at, the BTU value that you would see in your home if you've now started to blend, hydrogen with your natural gas.
Gotcha. And it's really the some of those difference in physical properties that allows you to determine the composition using an ultrasonic meter, because you can gauge the how much the speed of sound has changed. Is that accurate to say?
Absolutely, absolutely, and that is, I would even say that, one of the key areas that SICK has been able to utilize some of these differences is really whenever we start taking and looking at the effect of, the speed of hydrogen, speed of sound of hydrogen, and taking and looking at the heating value of hydrogen being that much lower. Mm-hmm. Those values, along with additional information, we can utilize that to quantify really within 2 mole percents of what the hydrogen is that's moving through our FlowSick ultrasonic meter. And that is huge if you are able to get a comparison value of 2 mole percents compared to what a process gas chromatograph would actually be deriving as the actual value it's determined that is moving through your pipeline system. And this information is also very critical as a validation point to ensure that your process gas chromatograph is accurate. But additionally, as that hydrogen is blended and it moves through a pipeline distribution systems network, then the question is, how is that blending being maintained throughout that whole distribution network? And so being able to have, that kind of an indication of that mole percent within a 2% kind of value is critical through an entire pipeline system.
And I'd imagine an ultrasonic flow meter is not cheap, but considerably less expensive than a gas chromatograph. Is that fair?
Absolutely. And much, much more cost effective to maintain.
That's absolutely true. So given the differences in some of the physical properties of gases, is there really a practical limit to how much hydrogen can be added? I mean, I would imagine that a pure hydrogen flow would not work well in most of the pipelines as they exist nowadays. Can you talk a little bit about what the limiting factors are?
Sure. And so, one of the important limiting factors is really driven by an organization called BAM, B-A-M, and that is the Federal Institute for Materials Research and Testing. And what this research gives us is it kind of spells out that the explosion group classification today, with anywhere from that 0, 5, 10% kind of numbers that we see that we would support today, has an explosion group classification of something called a 2A classification. And so one of the limiting factors is if you are operating with a mole percent of hydrogen up to that 25 to 30% range, that classification then moves from a 2B or a 2C kind of range. And so it's because of that kind of impact that there has been significant research conducted in really this area. For most pipelines are looking really to blend up to a 5 to 10% hydrogen with natural gas. Now, there is additional testing that's being conducted, at that 15%, the 20%, really even up to those 30% levels. Mm-hmm. But the driving focus that you see is really on safety and also being able to quantify what those lower carbon emissions are for pipelines. But a key driver of all of that is all around safety.
I imagine start at 5 to 10% for now, and then we can prove it out at higher levels once we have that much hydrogen to add. But certainly safety has to be that driving force. That makes a lot of sense.
It does, and also another piece of that is how much lower carbon emission benefit do you get from increased hydrogen? And so that is, what all of those studies are really focusing on is, what benefit that you get from the higher concentration of hydrogen. And so all that factored in with any safety related concerns at all.
I would imagine that, all the different types of burners and devices and all that kind of stuff has to be tested as well to make sure you're not getting some unexpected implications from a different gas flow as well.
Absolutely. I mean, the WOBE index, taking and looking at, the heating value, all of that factors into the burner design and what you see that is standard in homes in the US today.
Well, I think it's to me, whenever I hear pipeline, I think, custody transfer, or whether it's just, needing to know how much energy that flow is delivering to its destination, because that's really what you're paying for or what you're buying, that energy. So means we want to know the heat value of the gas being delivered, and that means both the flow rate and the composition of the blended gas. What it is about, we touched on it a little bit, but a little more on what it is about ultrasonic flow measurement technology that allows this to be done cost effectively in one instrument to get at that energy reading.
Sure. And so, this is a question that, as really a measurement person,
Yeah.
People talk about there being an energy meter, and just like what you're mentioning, we've got to know the energy value, and we've got to know the volume of gas, because those are critical to determine what is the custody transfer of gas. Mm-hmm. But in addition to that, we've got to also know the CO2 content, we've got to know the nitrogen content, we've got to know all of the mole percents that make up that natural gas, because there are implications, from a cricondotherm type perspective, and, the inner operations of that gas in its delivery. And so what the huge benefit that you receive, with an ultrasonic meter is really the ability to accurately quantify the velocity of the gas moving through the meter, and to know the exact speed of sound for that gas. And so with that information, based on the meter's configuration, its flowing parameters, this information provides that pipeline operator and that measurement technical operations staff the critical information to know the exact quantity of gas moving through that meter, and to ensure that the BTU and the gas composition that's being derived from that associated gas chromatograph is accurate in determining what that exact custody transfer volume and energy of gas being recorded by that meter is at that specific physical point. And that is critical through all of your pipeline operators throughout their entire infrastructure.
Yeah, that makes sense. Are there other advantages of 6 ultrasonic solutions relative to other flow measurement technologies when it comes to this sort of application?
Sure. And so if we take and we look at hydrogen measurement, we've been talking some of, blending hydrogen up to 30%, and 6 ultrasonic meters, our new latest ultrasonic meters being able to handle up to measuring 30% of that blended mixture of hydrogen today. But, if we take and we look at 6 ultrasonic meters that have been implemented throughout the world, including the US, have been measuring up to 100% hydrogen since 2005. Now, historically, that has been classified to operate within a 2% accuracy limit that wouldn't meet what you and I are talking about as far as a custody requirement today. However, measuring 100% hydrogen has been, possible with hydrogen meters for years today. And this is an area that is continuing to grow and improve to where around the corner, we will see custody transfer of hydrogen measurement at 100% hydrogen with ultrasonic meters, but that is just not there today. You see up to that 30% as a custody transfer type classification.
But I would imagine there's lots of applications within, say, a green hydrogen electrolyzer or those kind of applications where you can still do a pretty good job at 2% of measurement within the manufacturing applications. Yeah,
absolutely. And what really factors into that is the volume of hydrogen you need to measure and the volume of gas that you need to measure. And that factors directly into what ultrasonic meter and what metering technology makes the most sense for you at that time.
Makes sense. So when it comes to meters that are already out in the field, maybe have been out there for a while, are there ways they can be upgraded so that they're more hydrogen ready, I guess would be the term?
Absolutely, Keith. And so if we take and we look at, the flow-sick custody transfer meters that are in the field today, one key point to take into consideration is those meters are designed to handle a blend really up to 10% of hydrogen today. And so a meter that has been, implemented in the field and has been in operation, that meter today can handle up to 10%. However, if you really want to be able to expand that, our meters are easily upgraded to handle up to that 30% blended hydrogen and provide that gas quality indicator, that I was really kind of talking about before, so that you are able to know, are you within that 2% of what a process gas chromatograph would indicate for the mole percent of hydrogen that's moving throughout your pipeline network. And so we encourage customers to really have a hydrogen assessment conducted at your facility, because it's very possible and very probable that you may not need to actually perform any upgrade of your equipment at all if you're going to operate within that 5 to 10%. However, if you're going to expand that, or if you've got some unique type situations, we would encourage you really to have a hydrogen assessment conducted that we can really tell you what would be required, if any, as far as an upgrade at your facility.
Great. Well, thanks so much, Duane, for sharing your perspective with us today, and best wishes on this important application of SICK technology to make the world a greener, more sustainable place. If any of our listeners today want to learn more about SICK's offering in the realm of ultrasonic flow measurement, where can they go for more information?
Well, the best place really to go is, at info@sick.com. There have been some white papers that I have worked with our team in Germany that have been presented at, AGA conferences here in the US. And those papers have also been presented from a European global type perspective. But the best place to seek out information is really at info@sick.com. And we will respond to you, provide you links to those papers, answer any questions that you would have, and we look forward to doing so.
All right, great. Well, thank you, Duane, and thanks once again to SICK Sensor Intelligence for sponsoring this episode, and to you, our listeners, for tuning in. If you've enjoyed this episode, you can subscribe to Control Amplified wherever you find your podcast. Plus, you can find the full archive of past episodes at controlglobal.com. Signing off, until next time.